Oort cloud, and it's a huge cloud of chunks of ice swirling around the sun at its farthest reaches. This is much farther from the sun than any of the planets are. We are really far of those stars at once. So we're going to set a course for our first nebula. And right now, the Orion Nebula is called a stellar nebula. This big cloud of gas is a star factory. It makes stars to form little clumps. Like if you've ever made a snowball and you squish it together, it doesn't get a lot bigger, but it does get more stuff in it. That's what's happening here. These little snowballs of gas are spinning around, getting more and more stuff sucked into them, getting made by a star. This is Cassiopeia A, and it was left behind by a star that was reaching the end of its life. Most famous for these beautiful rings, which look solid, looks like you could walk on them. But once we get closer, you'll see they're actually made up of tiny chunks of ice and rock, swirling around Saturn at incredible speeds. Some of these pieces are as small as a pebble, some of them are as big as a house. So really, really cool ring of Saturn. That's no moon. That's the Death Star from Star Wars, right? All right, I'm sorry about that. Let me show you the real moon. Just keep an eye on this crater. Here's Mimas, lovingly referred to as the Death Star moon because of this crater on its surface. Although we didn't have a picture of the moon until after Star Wars came out, which is kind of fun. But here's Mimas. It sits just outside the rings of Saturn. And its gravity, its pull, actually tugs on the rings as well. And it keeps them looking as nice as they do with those pretty well-defined gaps. Without Mimas pulling on the rings from the other side, they would just start to kind of get smaller and move towards Saturn. But let's head to our next moon of Saturn for today. This is actually the biggest moon going around Saturn. We are flying to Titan. Titan is a very, very cool moon. We used to think it was the biggest in our entire solar system, but when we got a closer look, we realized we were measuring all the way out here. The moon itself only goes to about here. This dark orange fuzz is hiding the moon. And that dark orange fuzz is an atmosphere. An atmosphere is like a thick gas blanket that surrounds a moon or a planet, right? We've got an atmosphere here on Earth. That's what gives us air to breathe. It keeps us warm at night, all good stuff like that, just like a gas blanket. Now, Titan, as far as we know, is the only moon that we've ever found that has a thick atmosphere, about those ethane, methane lights. That is only possible because of the atmosphere of Titan. So please enjoy your ride across this alien moon. See these stars? That's what these white dots are. And the red lines show their orbits, their paths, how they're moving. Now, if you look right at the center, do you really see anything?
No.
Not really, right? There's nothing very obviously big and strong at the center. But we know something has to be there because the Milky Way doesn't just drift apart. So let's zoom in, let's get a closer look. It turns out that at the center of the Milky Way is a supermassive black hole. This is called Sagittarius A star, and it's 4 million times the mass of our sun. So this is as powerful as 4 million suns. Now, why can't we see it when we're farther away? Turns out it's because it doesn't give off any light. The reason we see the sun and the stars is because they give off light. The black hole's gravity is so strong that not even light can escape. Right here is called Andromeda, and it's the closest galaxy to the Milky Way. And even though it's the closest one, it is still over 2 million light years away. That means if you wanted to go from here to here, and you had a spaceship that could travel at light speed, it would still take 2 million years. Now, Andromeda was also, M87 is cool because it sits at the very center of this galaxy cluster. A galaxy cluster is just what it sounds like, a bunch of galaxies stuck together in space by gravity. M87 is big enough to hold other galaxies to it. And at the very center of M87 is, of course, another black hole. This one just so happens to be the first one that we took a real picture of. This is a real picture of a black hole. Black hole itself is in there, right? Can't see it, not giving off any light. But this orange fuzz is that accretion disk, that whirlpool spinning towards the center. All right, with that said, I have a question for you all. Do you think this is the whole universe?
No.
No, right? Do you want to see the whole thing?
Yes.
Yeah, let's zoom out. Let's take a look at our universe. This is our universe. At least the universe that we can see, right? This is our visible universe. I can't show you what we don't know is out there. It's possible the universe goes on even longer than this. You also might notice there's big gaps missing. And it's not that those places are empty, it's that we can't look there. Something is blocking our view. We think if we could see these parts of the universe, they would look like this, full of tiny purple dots, which represent galaxies. Once again, this is real data, actual galaxies we've discovered. And even though there's probably a lot more out there, for argument's sake, let's say this is it. Let's say we've discovered every galaxy that exists. Even if that's true, that's still 2 trillion galaxies that we gotta look at. Right into our Milky Way once again. Past some of those nebulas, those gas clouds, and through the edge of our solar system. Now, as we make our way back home to Earth, you'll notice there's a lot more galaxies in the sky than we can normally see. And just because, they're too far away for us to see with our eyes, they're still out there. So the next time you look up at the sky, remember what's up there just waiting to be explored, waiting to be discovered. There's so much cool stuff that we still don't know yet. So thank you all so much for joining us on this